Welcome to the Deep Dive. Today we're tackling modern artificial intelligence. Our mission, to really get under the hood, moving past this idea of AI as just, pure intelligence floating around in the cloud somewhere.
Yeah, that's a really convenient myth, isn't it? It lets us ignore the real footprint.
Exactly. So we're challenging that. We want to see AI for what it really is, a system that's deeply physical, political, and absolutely labor-intensive.
Right. Kate Crawford really laid this out with the Atlas of AI concept. It's built on actual stuff. Minerals dug from the earth, huge amounts of energy, often invisible human labor, and, well, concentrated corporate power that's pretty opaque.
We're going to trace that hidden structure. Look at the real-world costs, the places where governance is failing.
And for this deep dive, we're pulling together insights from, well, all over the place. Neuroscience, philosophy.
But also hard data, corporate transparency reports, military strategy documents. We're trying to pull out the really critical pieces about how AI is actually structured in society.
Things like built-in biases, the exploitation of workers that actually makes these systems seem smart, and the big geopolitical power games driving it all.
We'll explore that tension between how we think biological intelligence and how machines compute.
And the social costs, the hidden costs when these algorithms are so opaque.
Plus the massive governance challenges. How do you even regulate something this powerful, this systemic?
That's a huge question.
Okay, let's unpack this then. Where should we start? Maybe with the basics. What intelligence even means biologically versus, computationally.
Right. To get a handle on machine intelligence, it helps to look at our own blueprint first, the neocortex. People often call it the organ of intelligence.
Okay.
And picture this. It's basically like a napkin-sized sheet of neural tissue. Incredibly complex, obviously, but if you look closely at the structure, it's surprisingly uniform across different areas.
Wait, so the part that handles vision looks similar to the part that handles, say, abstract thought. That seems odd.
It does, doesn't it? It's kind of the paradox of the neocortex. It does all these different things: vision, hearing, language, planning. But the local wiring, the microarchitecture, looks remarkably similar.
So what does that suggest?
It suggests it's maybe a kind of general-purpose learning machine. The structure is flexible, and it's the connections it forms and the data it gets fed that shapes it into a visual processor or a language center.
And when we learn things, when we store knowledge, that's physical too. Not like saving a file.
Absolutely physical. Our whole model of the world, everything you know, isn't stored digitally. It's encoded in the connections between neurons, the synapses. Every time you learn something new today, make a new memory, you're essentially growing or strengthening synaptic connections. Your brain is literally rewiring its hardware based on your experiences.
But my conscious experience feels pretty smooth,
Yeah.
Stable. Yeah. If my brain is constantly rewiring and there's all this electrical buzzing everywhere, how do I get that feeling of a continuous self?
That's the crucial difference between the microscopic level and what we actually experience consciously. If you could zoom right into the neocortex, you'd see incredibly fast activity, changing constantly, almost column by column, hundreds of times a second.
Okay.
But we're not aware of that, not consciously. That super high-frequency local chatter isn't what breaks through into our awareness.
So what do we perceive then? A filtered version, a summary.
Kind of, yeah. You could think of it like that. What we perceive seems to be based on more stable patterns of activity across larger groups of neurons. Some researchers call them voting neurons.
Voting neurons.
Yeah, imagine all those little columns are like specialists constantly shouting out bits of information. The voting neurons span larger areas, and their activity represents a kind of stable consensus emerging from all that local noise.
Okay, I see.
It's this stable consensus pattern that gets passed along to other brain areas, the parts involved in language, memory, action. So the brain prioritizes a stable, usable narrative over the raw, chaotic data feed.
That makes sense for functioning day to day, but it sounds like it also puts a big limit on maybe self-awareness, knowing what's really going on in there.
It absolutely does. And this ties right into how we perceive ourselves. We tend to think consciousness is about discovering truth, right? External reality or internal states.
Yeah, usually.
But from a biological standpoint, self-perception might be fundamentally about something else. Physiological control, regulation, basically keeping the organism alive and predicting what it needs to do next. The brain acts like a prediction engine.
Running a simulation.
Exactly. It's constantly running an internal simulation of the world based on pretty limited sensory input and all its past experiences.
So we're not seeing the world directly. We're seeing the brain's best guess, its simulation.
That seems to be the case. We perceive the simulation, not raw objective reality. And that has a huge consequence, like you said. Our beliefs can be totally wrong, but because they're part of this core survival
They're
simulation,
incredibly hard to shake.
right, they become really resistant to evidence that contradicts them. That's the root of things like motivated reasoning or confirmation bias. Your brain isn't primarily optimized for absolute accuracy. It's optimized for efficiency and survival within its own model of the world. Hashtag 1.2, the computational path to artificial intelligence.
Okay, that's a fascinating, complex picture of biological intelligence. Now, shifting gears to machines, computers think, or maybe we should say compute, very differently, don't they? What's the main path AI has taken to get where it is now with models like GPT-3?
The path for AI has been overwhelmingly about one thing: scaling. Just massive, relentless, exponential scaling.
Unlike our brains, which seem to have a more fixed, flexible architecture.
Exactly. For computers, the most effective way found so far to boost intelligence is to take general methods, mostly deep learning, and just throw exponentially more computing power and exponentially more data at them.
And that scaling, that's where the physical reality, the Atlas part, really hits home. This isn't just code floating in ether.
Not at all. Scaling is profoundly physical. It demands huge amounts of minerals for the chips, silicon, gold, rare earths. It needs enormous, continent-spanning data centers, and the energy consumption. It's staggering.
We're talking industrial scale infrastructure.
Absolutely. Just think about the numbers. A few years back, Google talked about a language model with 1.75 trillion parameters. That's 9 times bigger than the original GPT-3.
Wow.
That single model effectively read more text than any human could read in, like, millions of lifetimes. The sheer scale is hard to comprehend.
And the physical footprint to train and run even one of those massive models,
Right.
that's a massive environmental and industrial cost that often gets glossed over.
It's a huge, often invisible cost. And these systems work so well, partly because of their underlying structure. We hear neural networks all the time. Maybe we could quickly look at one key type, the convolutional neural network, or CNN, especially for seeing things, computer vision.
Okay, yeah. How do they manage to recognize objects so well? I remember older types of networks struggled with that.
Right. If you had an older, sort of fully connected network and you trained it to see an eye in the top left corner of an image.
They would have to completely relearn what an eye looks like if it showed up in the bottom right corner.
Exactly. Inefficient. CNN's cracked this using 2 key ideas: filters, or kernels, and parameter sharing. They respect the fact that in an image, things that are close together usually relate to each other. Spatial locality.
Can you give an analogy for a filter? What's it doing?
Think of a filter like a tiny magnifying glass looking for a very specific pattern, maybe a 3 by 3 pixel area searching for a sharp vertical edge, or a little curve, or a specific texture.
Okay.
The genius part is the parameter sharing. The network learns that one filter, that one little pattern detector is useful, and then it slides that exact same filter across the entire image.
Ah, so it uses the same tool everywhere.
Precisely. It doesn't need a million different eye detectors for every possible spot an eye could be. It learns one good eye feature detector and applies it universally. That sharing makes them incredibly efficient for visual tasks. So we've got machines getting incredibly good through scaling and clever architecture like CNNs. But this brings us right up against a really deep philosophical wall, one that connects back to our biological intelligence: the problem of intentionality.
Intentionality. Okay, that sounds academic, but I sense it's crucial here. What does it mean in this context?
Intentionality is that quality of our minds where our mental states, like your belief about the weather or your desire for coffee or feeling ashamed about something, are about something. They're directed at, or they refer to, things or situations out there in the world.
The aboutness of thought. My thoughts point to things.
Exactly. And the deep philosophical puzzle is, how does purely physical stuff, like the neurons in your head, which are ultimately just, atoms bumping around according to physics and chemistry, how does that stuff come to represent anything? How does a pattern of firing neurons suddenly mean, I think it's raining?
Right. How does meaning emerge from mere matter?
That's the question. And it's the core of the famous critique against strong AI. The idea that we can build machines that don't just simulate thinking, but actually understand and are conscious. This is where John Searle's Chinese room thought experiment comes in.
Ah, yes, the Chinese room. Remind us how that works.
Searle imagines a person locked in a room who doesn't understand a word of Chinese. They have a huge rule book written in English that tells them exactly how to manipulate Chinese symbols. So Chinese questions come in through a slot. They follow the rules perfectly, look up the symbols, combine them according to the instructions, and send perfectly grammatical Chinese answers out.
So from the outside, it looks like the person in the room understands Chinese perfectly.
Right. The outputs are flawless. But the person inside still has absolutely no clue what any of those symbols mean. They're just manipulating symbols based on rules, syntax, without any understanding of the meaning, the semantics.
And Searle's point is that a computer running a program is just like the person in the room. It's just manipulating symbols.
That's his argument. A computer defined just by its formal computational processes running a program over symbols can simulate understanding, it can mimic the formal properties of thought, but it can never achieve genuine understanding or intentionality. It doesn't know that the symbol cat refers to actual furry animals.
Okay, but let's push on that a bit. If these large language models get so good that their output is essentially indistinguishable from a human, if the simulation is perfect for all practical purposes, why should we, or you listening, care if it really understands or just simulates understanding? Doesn't the useful output matter more than the philosophical purity?
That is the absolutely critical practical question. And maybe, for many tasks, a perfect simulation is good enough. If it writes great marketing copy or summarizes documents flawlessly, maybe we don't need real understanding.
Right.
But if it lacks genuine intentionality, if it doesn't have real beliefs or desires or a connection to the world, its intelligence might be brittle. It lacks that biological drive for survival that underpins our own error correction and adaptation.
Yeah.
It can't truly reflect on its own assumptions or its ethical framework because it doesn't have an intrinsic self or goals beyond statistical pattern matching. It's just predicting the next word based on its training data. It might generate text that sounds ethical, but it doesn't believe it. That difference matters when things go wrong or when you need nuanced judgment beyond the training data. It's the difference between mastering the syntax of language and grasping the deep semantics of meaning and consequence.
Okay, moving from philosophy to the, let's say, on-the-ground reality. These systems we've described scaled up, statistically driven, they're being deployed everywhere now. And they're far from neutral actors, are they? They bring huge social and ethical costs. This really proves AI isn't just some benign tool. Hashtag tag 2.1 real-world harm and algorithmic bias.
Absolutely not benign. One of the most glaring areas where we see real harm is how AI can amplify existing biases, especially in the criminal justice system.
You're talking about these like risk assessment tools?
Exactly. Tools like COMPAS, for example. Many U.S. states actually mandate their use now. These algorithms look at a defendant's data and spit out a score high, medium, or low risk, predicting the likelihood they might reoffend or fail to show up for court.
And judges use these scores, potentially deciding whether someone stays in jail before they're even convicted.
That's right. It heavily influences pretrial detention decisions. And the huge problem is these tools often end up placing a disproportionate burden on poor people and minority groups. They essentially bake in and reinforce existing cycles of inequality.
How does that happen? Is the algorithm itself biased?
It's more that the algorithm learns from biased data. It's fed historical crime and arrest data, right? But that data reflects decades of policing practices that themselves might have been biased, maybe over-policing certain neighborhoods or targeting specific groups.
So if police historically arrested more people in neighborhood A than neighborhood B, the AI learns that people from neighborhood A are inherently higher risk.
Precisely. High policing leads to high arrest stats, which the algorithm sees as high risk, leading to higher risk scores, which can mean more pretrial detention, which makes it harder to build a defense, often leading to worse outcomes. It becomes a self-fulfilling prophecy, statistically validating the original bias.
Wow, okay. And we see similar issues, this lack of scrutiny and potential for harm in other critical areas too, like healthcare.
Yeah, the EPIC sepsis model example is really telling here. Sepsis is incredibly dangerous, a leading cause of hospital deaths. EPIC, a huge player in electronic health records, developed an AI model they claim significantly reduced sepsis mortality. Sounds great, right?
Sounds amazing.
And hundreds of hospitals adopted it really quickly based on EPIC's claims. But here's the catch. EPIC released 0 peer-reviewed studies. No independent third-party validation of its accuracy or effectiveness was made public. They basically said, trust us, it works, but the details are a trade secret.
So doctors and hospitals were relying on a life-or-death prediction from a complete black box. That seems dangerous.
It's incredibly dangerous, not just because of the secrecy itself, but the immediate clinical risks. If the model is opaque, how can doctors understand its limitations? Maybe it works well for some patient groups, but performs terribly for others.
Right. Could have hidden failure modes.
Exactly. Clinicians might get a false sense of security, misdiagnoses, because the algorithm didn't flag something, especially if it has blind spots for certain demographics or under specific conditions. Without open auditing, the medical community can't find and fix potentially lethal flaws.
Beyond these direct scoring or diagnostic harms, AI bias also shapes our information environment, right? Through things like filter bubbles.
Oh, absolutely. This is a huge part of the political dimension of AI. The algorithms running your search engine, your news feed, your social media, they're constantly building a profile of you. Your location, your clicks, what you like, what you share, your inferred political leanings.
And they use that profile to tailor what I see.
Aggressively. The main goal is usually maximizing your engagement, keeping your eyeballs glued to the screen to sell more ads. And the easiest way to do that is often to show you stuff you already agree with, things that provoke a strong emotional reaction, often outrage or affirmation.
Which leads to the filter bubble.
Exactly, you get trapped. The algorithm creates what Eli Pariser called persuasive marketing for the very views that we already hold. It filters out challenging ideas, complex nuances, or perspectives that might make you uncomfortable, or just click away.
And the result is more polarization,
Yeah.
more tribalism.
It certainly seems to contribute significantly. It makes shared understanding or nuanced public debate incredibly difficult when everyone's living in a different, algorithmically curated information reality. The system isn't optimizing for truth or social good, it's optimizing for clicks and watch time, which often means feeding you more of what you already believe or what makes you angry.
This secrecy you mentioned with the EPIC model, or the way risk assessment tools are often proprietary, it feels like part of a bigger pattern in AI development, a sort of transparency crisis.
It absolutely is. You could even call it the captivity of science by commercial interests. The intense pressure and massive investment driving the race to commercialize generative AI, especially from giants like OpenAI and Google, has led them to wall off crucial technical information.
Stuff that used to be shared openly in research.
Yeah, things that traditionally would have been published in academic papers for scrutiny details about the data sets used for training, the exact size and architecture of the models, known weaknesses or failure modes, how they perform on different demographic groups. Now, much of that is treated as a valuable trade secret.
Protecting their competitive edge, presumably. But at what cost? Do we have any hard data on how bad this lack of disclosure actually is?
We do, unfortunately. Stanford researchers put together a foundation model transparency index in 2023. They tried to track whether major AI companies were disclosing even basic information needed for external accountability.
Like what kind of information?
Things like, how many parameters does your model actually have? What specific data sets did you train it on, not just the internet, but the specifics? Did you have independent auditors verify its performance, especially regarding fairness and bias across different groups?
And the results?
The results were pretty damning. Of the 10 major companies they looked at, including all the big names in generative AI, every single one received an F grade for transparency.
An F. Wow. So, for all practical purposes, these incredibly powerful systems are black boxes, even regarding basic metrics. What's the downstream effect of that level of secrecy?
The effects are huge, and they're fundamentally about power. This secrecy locks in the dominance of a very small number of massive tech and finance companies. They get to make incredibly consequential decisions in secret.
Decisions that affect millions of people.
Absolutely. Think about the algorithms used for financial credit scoring, deciding who gets a loan, or Google's internal rules about what content gets flagged for piracy, which has massive implications for creators and publishers. These decisions, shaping economies and access to information, happen behind closed corporate doors.
And without transparency, there's no way for the public or even regulators to effectively challenge or even understand the basis for those decisions.
Pretty much. It becomes, as one analysis put it, well-nigh impossible for outsiders to assess the real-world impacts. When the tools shaping society are deliberately kept opaque, the people who do have the knowledge, the companies building them, gain enormous unchecked power. That's the deep political risk of this opacity. Hashtag TagTag 2.3, the accountability gap in autonomous systems.
This opacity, this lack of accountability, it seems like it would reach its most dangerous point when we talk about AI and warfare. specifically things like lethal autonomous weapon systems or law of dim use.
Yes, and the discussion there often gets complicated, sometimes deliberately, by arguments over wording, over nomenclature.
How so?
Well, for example, some military organizations, like in the UK, make a careful distinction. They talk about autonomous systems as something futuristic, like hypothetical human-level AI. Then they talk about current or near-term tech as automated weapons systems that can find, pick, and attack targets on their own, but maybe aren't truly autonomous in that sci-fi sense.
So by defining autonomous as something far off, they sidestep the ethical debate about the weapons we can build now.
That's a concern, yes. It can shift focus away from the very real ethical and legal challenges posed by weapons systems that already possess significant degrees of automation in the kill chain.
And regardless of the label, deploying weapons that can select and engage targets without direct human control raises a huge issue. The accountability gap. What is that exactly?
The accountability gap is this problem. If a machine makes the final decision to kill, who is responsible? Is it the commander who deployed it, the programmer who wrote the code, the manufacturer? If responsibility becomes diffused, if the humans involved don't feel directly accountable for the act of killing,
It creates a moral hazard.
precisely, it could lead to carelessness, maybe even reckless behavior in how these weapons are used. People might be more willing to deploy them if they feel psychologically or legally distanced from the consequences. Even if the weapon technically complies with the laws of war on paper, applying complex principles like proportionality or precautions in attack becomes incredibly difficult when a machine is making judgments humans used to make.
And beyond the individual accountability, there's a risk to overall global stability, isn't there? If automation speeds up military decisions too much.
That's a critical point, especially in crisis situations between major powers, potentially nuclear-armed ones. Automation can be useful, even stabilizing, if it helps humans manage information better. But it becomes dangerous if it replaces human judgment and accelerates decisions beyond human capacity for reflection.
Especially in a tense standoff.
Exactly. Crisis management between nations often involves incredibly delicate signaling, trying to show resolve but also limits, trying to understand the other side's intentions. It requires interpretation, empathy, understanding context, often called theory of mind.
Which current AI is famously bad at.
Woefully unequipped, really. Today's AI can't read intentions, understand historical context, or grasp the subtle ambiguities of human communication in a high-stakes crisis. It can't imagine what the opponent might be thinking or feeling.
So plugging high-speed, automated decision-making into that delicate loop.
Could be disastrous. It risks bypassing necessary human deliberation, leading to miscalculations and potentially rapid unwanted escalation because the machine misinterpreted a signal or acted purely on pre-programmed rules without understanding the bigger strategic picture.
Okay, so we've looked at the myth of AI as a disembodied brain and the myth of AI as a purely benign force. Part 3 digs into the foundation. The huge structures of money and, crucially, labor needed to actually build and train these systems. This gets to the core of the Atlas framework, the hidden human cost. Hashtag take 3.1, the hidden labor of ghost work.
Right. That incredible sophistication we see in AI systems today, it doesn't just magically appear from algorithms. It's built on millions upon millions of hours of human labor, often invisible labor, sometimes called ghost work.
Ghost work.
Yeah, it refers to these vast, hidden economies of workers doing tasks that are essential for making AI work, tasks that computers can't do well yet. The platforms that manage this work often claim they're just software efficiently coordinating tasks.
But the work itself, the often tedious, difficult tasks, they don't vanish.
No, they just get outsourced and offloaded onto this huge, distributed, often precarious workforce. And the platforms cleverly shift many of the costs, things like quality control, training, dealing with disputes, even finding the next task onto the workers themselves.
So the efficiency is partly achieved by making the workers bear the friction costs.
Exactly. Workers can lose hours, even pay, trying to figure out confusing instructions or dealing with rejected work, often with no real way to appeal. And there's a massive power imbalance. The requesters, the companies needing the work done, can always find someone else, somewhere in the world, willing to do it for slightly less. This creates constant downward pressure on wages.
What kinds of tasks are we talking about here? Can you give some examples?
It's incredibly varied. It could be content moderation, people spending hours watching disturbing videos or images to train AI safety filters. It could be labeling data for self-driving cars, meticulously identifying pedestrians, traffic lights, lane markings, and thousands of images.
Tedious stuff.
very tedious. Or transcribing garbled audio, checking the output of machine translation, evaluating search results for relevance. Basically, humans are constantly teaching, correcting, and cleaning up after the algorithms. Without this invisible human scaffolding, many AI systems would simply collapse or perform terribly.
And the way this work is structured makes it hard for these workers to, say, organize or push for better conditions.
That's a key feature, or maybe a bug, depending on your perspective. The platforms emphasize flexibility work whenever you want, from wherever, on whatever task is available.
Which sounds good on the surface.
But that very flexibility undermines the traditional ways workers gain power. To effectively organize and bargain collectively, workers usually need some combination of three things: a shared physical workplace, shared working hours, or a strong shared professional identity.
And ghost work typically has none of those.
Right. Workers are often isolated, competing globally, working different hours on fragmented tasks. It makes building solidarity and collective action, the things needed to negotiate for better pay, benefits, or dispute resolution, incredibly difficult. They're treated more like interchangeable cogs in the machine, which might be efficient for the platform, but leaves the individual worker very vulnerable. Hashtag tag 3.2, the concentration of corporate power and direction.
So the labor costs are often hidden and diffused. But the capital driving AI development and deciding what kind of AI gets built, that seems incredibly concentrated, bringing us back to the political dimension. What forces shape the direction AI research actually takes?
Overwhelmingly, the direction is set by a relatively small group of very powerful actors, large tech corporations, venture capitalists, and aligned state interests, and their priorities tend to focus on areas like automation, surveillance, and large-scale data collection.
Why those areas specifically?
Well, fundamentally, because that's where the profits and power consolidation often lie. Technology gets directed towards things that can increase corporate efficiency, like automating jobs, enhance control, like worker monitoring, or create new markets based on data monopolies. This path tends to reinforce the wealth and influence of those already at the top.
Even if those technological choices aren't necessarily the best for society overall, like maybe they increase inequality or reduce privacy.
Yes, that's a major concern. The choices made about which AI applications to pursue and fund aren't neutral. They reflect the values and interests of those with the capital. Social costs, like job displacement or erosion of privacy, might be seen as externalities and unfortunate side effects, rather than reasons to change course.
We've even heard about pretty intense conflicts inside some of these major AI labs, haven't we? Fights over the pace of development and safety versus commercial pressure.
Absolutely. There have been reports, often from researchers who later left or raised alarms, about situations where critical decisions like whether or how to release a massively powerful new model like GPT-3 or GPT-4 felt like they were pushed through by leadership.
Like the decision was already made.
Yeah, dissenters described feeling like safety concerns were heard but ultimately sidelined, that the process was manipulated to reach a foregone conclusion favoring rapid deployment. Some even used terms like gaslighting to describe how their concerns were handled. These internal struggles highlight governance systems within these powerful organizations that may prioritize speed and market share over deep consensus on safety and ethics.
This concentration of power and the race for deployment, it immediately spills over into geopolitics, doesn't it? Given how resource-intensive this all is.
It absolutely does. The AI race isn't just about software. It's increasingly about controlling the physical supply chain, access to cutting-edge semiconductor manufacturing, control over the vast data sets needed for training, securing the energy resources.
Nations see AI dominance as strategically vital.
Completely. There's a widely quoted sentiment, often attributed to various leaders, that the nation leading in AI will be the ruler of the world. Whether that's hyperbole or not, governments certainly act as if it's true. This fuels an intense global competition.
And competition like that can create instability, maybe even incentivize conflict.
That's a serious risk. When potential adversaries are all racing to develop potentially transformative AI capabilities, especially for military use, it creates huge uncertainty. If country A fears that country B is about to achieve a decisive AI advantage that could threaten its security,
Country A might be tempted to act first, to preemptively stop them.
that's the logic of preemptive conflict driven by technological uncertainty. We're already seeing elements of this play out in things like fierce competition over chip manufacturing technology like TSMC in Taiwan and the use of export controls on advanced semiconductors. These are direct geopolitical moves aimed at strategically slowing down a rival's AI progress. Hashtag 3.3, the shifting economics of work.
Okay, let's bring this back to the broader economy and the impact on jobs. We've touched on automation. Historically, technology has always disrupted work, right? The loom displaced weavers, the tractor displaced farmhands.
Right. But the historical pattern, broadly speaking, was that while old jobs were destroyed, technology also created new jobs. And often, those new jobs required different, sometimes higher level skills.
So the workforce adapted, moved up the skill ladder.
Generally, yes. The shift went from predominantly manual labor towards manufacturing, then towards service industries, and increasingly towards cognitive, knowledge-based, white-collar work management, analysis, design, programming, law, medicine. Technology, in the aggregate, tended to complement human cognitive labor, making it more productive.
But the fear now with this latest wave of AI, especially generative AI, is that this time might be different.
That is the core anxiety, yes. Because previous waves automated muscle power or maybe routine cognitive tasks. But models trained on basically the entire internet. Models that can write code, draft legal arguments, create marketing plans, generate images. They seem capable of climbing much higher up the ladder of human cognitive skills.
So instead of just automating routine tasks, they might automate complex, non-routine white-collar work.
That's the potential disruption. If AI can perform a significant chunk of the tasks currently done by knowledge workers, maybe not perfectly, but efficiently and cheaply enough, the historical pattern where displaced workers could move up into new cognitive roles might break down.
Because the machines are now climbing the same ladder, there might be fewer higher rungs left for humans to move to.
Exactly. We face a plausible scenario where advanced AI doesn't just complement cognitive labor anymore, but starts to directly substitute for it at scale across many white-collar professions. If that happens, the fundamental economic relationship between technology and human work, which has held for centuries, could radically change. It raises profound questions about income inequality, the value of human skills, and how we structure society when maybe, just maybe, there isn't enough high-value cognitive work left for everyone. #outro.
So we've covered a lot of ground in this deep dive, really trying to build that atlas of AI. We started by taking apart the idea of intelligence itself, seeing our own minds as physical prediction engines running a simulation, which is vastly different from the computational, scaling-driven approach of AI that needs immense real-world resources.
Yeah, and then we traced the consequences of deploying those scaled systems. We saw how they embed societal biases, leading to real harms in areas like criminal justice. We saw the danger of opacity, like with the epic sepsis model, where secrecy trumped safety.
And we uncovered the hidden labor propping it all up, the often exploitative ghost work, plus the concentration of corporate and geopolitical power that steers AI development towards specific, often self-serving goals.
And pulling it all together, what the Atlas reveals isn't some ethereal intelligence, but, as you said, complex systems of social control, hidden dependencies on labor and resources, and immense corporate power that operates with very little transparency. The path we're currently on, more automation, more surveillance, more data consolidation, it feels inevitable, but it is a choice. It's shaped by specific interests.
Which makes governing it incredibly hard. How do you regulate something effectively, whether through taxes, rules, alignment research, when the core technical details of the most powerful systems are deliberately kept secret?
It's a massive hurdle. The opacity directly undermines effective governance and public trust.
And that brings us to a final, maybe provocative thought for you, our listener, to consider. Many people in the AI field talk about the long-term goal of creating superintelligence, something incredibly powerful, but also safe and reliable, hopefully aligned with human values, able to maybe even fix its own mistakes.
Right, the AGI safety discussion.
Exactly. But if that's the ultimate aspiration, how can society build the necessary trust to even approach that goal when the industry building today's most powerful AI models currently gets an F for transparency, when they actively obscure how these systems work and hide the real-world harms they're already causing?
It's a fundamental contradiction, isn't it? Building trust for the future while eroding it in the present.
It seems we need to grapple much more seriously with the immediate systemic risks of the AI we have now. The bias, the opacity, the unaccountability in our courts, hospitals, information systems, even military contexts, rather than focusing only on speculative future dangers. The foundations we lay today with transparency and accountability will determine what kind of future AI systems we actually get.
Well said. The present challenges are urgent.
Thank you for joining us on the Deep Dive. We hope this gave you a clearer map of the real territory of AI. We'll be back soon.